In this module, we will explain the high-level elements required in the oil and gas space, describe oil and gas industry standards and protocols, present key IT oil and gas requirements and explain IT considerations of availability, redundancy, wireless connectivity, and secure remote access for the oil and gas industry. In this lesson, we will present the high-level elements required in the oil and gas space, describe how traditional oil and gas networks work, and review a high-level diagram of an oil and gas distribution network. Within the next 20 years, energy demands for oil and gas are expected to increase exponentially. In preparation, oil and gas companies are starting to make some major changes in the way they operate. The oil and gas industry is looking for ways to modernize their global operations. While dealing with an already complex framework, the need is great to be able to access key information, track operations real-time, and resolve supply chain issues quickly through the use of automated technology. However, considerations like harsh ocean environments, Arctic temperatures, hundreds of miles of pipelines, and oil refineries that are decades behind in technology make it a challenging endeavor. The Internet of Things, IoT, offers a way for oil and gas companies to connect all parts of their operations across the globe. By connecting more physical objects to the Internet, companies can benefit from the knowledge and efficiency gains of a digitalized and automated world. The oil and gas industry consists of many separate parts that work together to bring fuel, natural gas, and other products to consumers. At a high level, the oil and gas ecosystem consists of drilling companies that extract natural reserves from land and ocean hydrocarbon basins, piping and pumping stations that transport crude oil and gas materials to storage and refining facilities, refining facilities that process raw materials into usable oil and gas products, transportation and logistics organizations that deliver oil and gas products to retail stations, national and international consumer-facing organizations such as BP or Exxon that provide oil and gas products to the masses. In this lesson, we will review drilling, piping, and refining in more detail. We will start with onshore oil and gas wells. An oil well is designed to lift crude oil from deep underground to the surface of the earth. In some cases, natural gas can be captured with the oil during this process. A gas well is designed to extract natural gas only. These wells are made by boring holes several centimeters to 1 meter in diameter into the earth using complex drilling machinery. In many cases, the natural process of the subsurface well is sufficiently high enough to push oil or gas to the surface, but in other situations such as decreased pressures caused by other producing wells or low permeable oil reservoirs, machinery is needed to help draw oil or gas to the surface. Smaller diameter tubing can be used to help, but additional lift functions may also be required. Common solutions include shallow well pumps, gas lift or surface pump jacks. In the oil and gas ecosystems, the control network will tie directly to devices such as pressure gauges, flow meters, pump controllers, valve actuators, and other control elements. Offshore oil and gas drilling is more complex than onshore installations because of the remote and challenging ocean environments. Innovations in the offshore oil and gas production are designed to overcome those challenges. Often, very large production facilities are installed to withstand the harsh ocean environment and to stand in depths of over 600 meters. Another kind of offshore oil and gas platform may keep afloat with a mooring system to hold it on location. This approach has several benefits in terms of cost for the case of deeper water installation, but creates challenges for the drifting and lifting systems due to the dynamic nature of the platform. Oil and gas pipelines are used to transport crude oil and gas to storage and refining facilities for processing. Some pipeline can be seen above ground, however they are more commonly buried underground. Oil pipes consist of steel or plastic tubing, while natural gas pipes are typically made from carbon steel. Pump stations are used to move the oil through the pipelines with speeds of up to 6 meters per second. In some cases, one pipeline is used to transport several different products in a sequence. In these situations, multi-product pipelines can be used. Since oil and gas pipelines are exposed to outdoor elements, they must be protected from erosion and regularly maintained by field technicians. An industrial oil refinery is where crude oil is processed and turned into products like gasoline, diesel fuel, kerosene, and so on. Tank farms are used to store crude oil and other bulk liquids. Oil is siphoned from the tank farms into the refinery for processing. Crude oil then goes through a series of chemical processes to become an end product or an ingredient for products such as plastics, solvents, detergents, and nylon and polyester fibers, among others. Refinery facilities are similar to manufacturing plant faculties and therefore have similar automation components and industrial network requirements. In order to bring all the components of the oil and gas system infrastructure together, Cisco Unified Solutions has developed a vision. Cisco Unified Solutions Oil and Gas Vision is a continuous process of the following elements. Seamless communications between central control centers and remote operating teams allow for real-time decision-making and collaboration between experts in the operations center and remote field technicians. Enhanced health and safety environment, monitoring and compliance, allows oil and gas operators to accurately locate personnel and assets and enables real-time monitoring of environment conditions. Integrated logistics, maintenance and operations allows operators to track assets, detect issues and plan predictive maintenance. Real-time operation and automation improves production, operations and provides process feedback and status for better control decisions. Virtual and remote operations enable field personnel access to the network from mobile devices, allow for remote collaborations and reduce the number of site visits. Let us review how each component of the oil and gas industry is impacted by this vision. On a connected gas or oil field, a modernized unified solution will allow secure and seamless communications between crew, control centers and other remote operations with the use of wireless technology. Enhanced personnel, health, safety and compliance with real-time tracking and alerts and safety security surveillance. Integrated maintenance and operations through the use of industrial control information and equipment location capabilities. Faster and better decisions made through the use of real-time data and status information in graphical format. More effective field collaboration and remote export support through mobile phone, tablet and wireless access point. On a connect gas or oil pipeline, a modernized unified solution will allow field personnel to have access to pipeline information and expert collaboration via mobile wireless hotspots and direct network connectivity. Enhance personnel and equipment safety through real-time tracking and alerts and safety security surveillance. Operational integrity through automated alert and notification systems. Access to status information and operational reports through real-time data acquisition. On-demand collaboration and expert support through mobile handheld devices such as cell phones and tablets. Within a connect gas or oil refinery, a modernized unified solution will allow wireless technology to support sensor networks, wireless automated devices and mobile HMI access. Enhance security through authorization and identification systems. Optimize processing through automation devices and control capabilities. Access to real-time process alerts and status information, access to the network status information via secure VPN support on mobile devices such as cell phones and tablets. Overall, the move to a unified oil and gas solution provides many benefits to all phases of the operation. In a connected oil field, a unified solution will allow remote monitoring of sensors that control the process of oil and gas extraction, as well as measuring pressure and volume to enable management of the extraction process. In offshore operations, a unified solution will enable a variety of digital strategies through the use of a reliable and secure wireless network. To ensure safe pipeline operations, a unified solution will utilize leak detection systems and predictive maintenance solutions to enhance operational integrity. In a smart and connected refinery, a unified solution will maximize operations with real-time digital automation and controls. In this lesson, we will present regulatory policies, standards and protocols for the oil and gas industry. In the United States, the Federal Energy Regulatory Commission, or FERC, regulates the transmission of natural gas, oil and electricity between states. The FERC monitors energy markets, focusing on energy costs, safety regulations and overseeing environmental impacts caused by energy production. The FERC ensures energy operations are conducted consistently and reliably. For example, it ensures availability of natural gas for customers by investigating potential fraud. Internationally, additional country or area-specific regulatory bodies such as the Council of European Energy Regulators, exist to perform similar tasks. To guarantee the safe and consistent delivery of oil and gas to consumers, the oil and gas industry recognized the need to develop and consent to globally acknowledged set of standards. The standards are created by the following regulatory organizations. The American National Standards Institute is the US representative to the International Organization for Standardization, which is part of the United Nations. ANSI monitors the development, promulgation, and implementation of standards and guidelines that impact, among other industries, energy distribution. The International Society of Automation is a non-profit global organization that sets the standards for industry automation. ISA certifies industry professionals, offers training and education, and publishes literature for automation professionals. National Fire Protection Association is a national organization charged with preventing fire and other hazards from impacting the environmental quality of life. The NFPA develops and promotes codes and standards, conducts research, and offers training and education. Since oil and gas are explosive materials, there are organizations dedicated to the health, safety, and impact of the oil and gas industry has on their employees and their environment. DNVGL, a classification society and certification body, offers expert advice to maritime, oil and gas, and energy industries, helping them to be safer, smarter, and greener. Services include the following: classifying potential hazards and risks, inspecting system processes to ensure they meet industry regulations, implementing risk management software, offering industry training and education. ABS Group is an offshore classification organization that offers expert advice and services to ensure the safety of offshore vessels and onshore oil facilities. Services include the following: developing a recognized set of standards, providing site surveys during new construction, inspecting materials, equipment and machinery, surveying sites that have endured damage or require updates or modifications. A potentially explosive atmosphere is formed by a mixture of gases, vapors, fogs, or dust, which can ignite under certain functioning conditions. Such conditions and hazardous equipment are found on fixed offshore platforms, in petrochemical plants, and oil refineries. ATEX, derived from the French term atmosphère explosives, consists of two European directives created to protect workers who are exposed to potentially explosive environments. From the ATEX directives, a set of Dangerous Substances and Explosive Atmosphere Regulations, or DSIR, were created and put into place for any employee working in a potentially hazardous location. The regulations mandate that equipment and safety control systems are certified for explosive atmospheres and marked accordingly. There are three ATEX zone types that apply to the oil and gas industry. Hazardous equipment and areas are classified based on their risk level and labeled accordingly. The classifications differ, however, between the European model and the North American model. It is important to note these differences. Let's take a look at the classifications now. In Europe, Zone 0 is in an area in which an explosive mix of material is often or always present. Zone 1 is in an area in which an explosive mix of materials is occasionally present in the normal conditions. Zone 2 is in an area in which explosions are seldom present in normal conditions but may accidentally occur. In North America, the classifications are consolidated into two divisions. Class 1, Division 1, is an area in which an explosive mix of materials is normally present. Class 1, Division 2, is an area in which an explosive mix of materials is not normally present but may accidentally occur. Many of the standards and regulations developed by regulatory agencies focus on controlling conditions in a hazardous location. A hazardous location is characterized by its potential danger, such as frequent fires or explosions. Depending on the characteristics of the location, such as the presence of flammable gas, liquid or combustible dust or fiber, potential danger may be normal or abnormal condition. According to NFPA's National Electric Code, there are three types of dangerous locations. Class 1 includes vapors, gases and liquid. Class 2 includes dust. Class 3 includes flying, debris and fibers. The division assigned to a location determines how frequent hazards occur. For example, Division 1 means the location is typically explosive and hazardous, while Division 2 means the hazard is not normally present but may accidentally occur. The example diagram highlights the difference between hazardous and non-hazardous locations within a typical industrial facility. Highlighted in red, number 1 is a Class 1 Division 1 area, which means it is explosive and hazardous. This area should be approached with caution as it is normally in an explosive state. Highlighted in yellow, number 2 is a Class 1 Division 2 area, which means it is potentially hazardous. This area is not normally hazardous but may accidentally become so. Highlighted in blue, number 3 is a non-hazardous location and does not contain a threat of becoming explosive. In modernizing the oil and gas industry, Ethernet IP with CIP sync and motion technologies is an ideal network for oil and gas refineries because it supports both non-industrial and industrial communications on a common network infrastructure. An oil refinery is a type of process manufacturing facility. As we reviewed in manufacturing, Ethernet IP controls automated devices and process components, such as intelligent input-output devices to dedicated controllers, human-machine interface communications, controller-to-controller interlocking, and data collection and integration with IT and manufacturing execution systems, or MES. Profibus is an international standard for industrial automation and has been used in the oil and gas industry for many years. It has been used on drilling rig devices to extract oil from reservoirs, to control the flow of crude oil within pipelines, and to automate devices in oil refineries. Profinet is the Profibus International Open Industrial Ethernet standard that uses TCP/IP and IT standards for automation control. It provides a fast and reliable way to access powerful diagnostic information and troubleshoot issues quickly. This is possible because it precisely controls data transmission for instrumentation and test equipment, as well as emphasizes data exchange and defines communication paths to meet speed requirements. The Profibus and Profinet protocols are used as follows. In upstream activities, Profibus DP and Profibus PA are widely used on the drilling rigs in the extraction and production phase. In midstream activities, with pipelines becoming the preferred method to transport crude oil, field buses are being used to control this flow to the refineries. In downstream activities, a refinery is the classic process automation example, and since these use hazardous or explosive environments, Profibus PA is the ideal fit. Profinet is not prevalent in downstream yet. The Highway Addressable Remote Transducer or HART protocol is widely used in the oil and gas industry to support communication between smart devices. The HART protocol supports a self-healing mesh network and is common in field networks found in remote drilling locations and pipeline operations. The HART standard provides field technicians access to operational monitoring and control systems and remote expert collaboration through handheld devices, laptops, and so on. The HART communication protocol allows oil and gas controllers to remotely calibrate smart devices and access diagnostic information online. The Modbus protocol supports communication between master-slave, client-server applications and intelligent devices. Modbus is used by hundreds of vendors to transfer discrete, analog, input-output and register data between control devices. Modbus oil and gas controllers have the ability to access master-slave applications in order to monitor and program devices, receive sensor and instrument data on an intelligent device, use PCs and HMIs to monitor field devices. In the future, the slave devices will become client devices and will be attached via Ethernet in a star or ring topology. In this lesson, we will review key IT oil and gas requirements and explain the IT considerations of availability, redundancy, wireless connectivity, and secure remote access for the oil and gas industry. A highly competitive energy industry is driving oil and gas companies to improve efficiency, productivity, and safety. A robust and adaptive IP network, including an industrial Ethernet infrastructure, is critical to the success of this implementation. There are several key IT requirements for these architectures: availability and redundancy, wireless connectivity, and secure remote access. In distribution and management networks, the components for oil and gas production are similar to those found in manufacturing. Sensors detect pressure, level, and flow in a variety of oil and gas applications. Instrumentation and meters are used to measure gas or oil volumes, or amounts of gas or oil transported through the pipe. IP cameras are connected via wired or wireless network and are widely used in oil and gas production and distribution systems for processes monitoring intruder detection and so on. Programmable logic controllers control a segment of the cell area process, such as draining a specified amount of raw oil from a stored tank into a holding tank for processing. Supervisory control and data acquisition, or SCADA, and distributed control systems, DCS, transmit data from IEDs and sensors within an oil and gas distribution network to the control center for analysis. If action needs to be taken, DCS and SCADA systems can be used to control the process remotely. A human-machine interface, or HMI, presents a graphical interface to a PLC or DCS. A human operator monitors and interacts with devices in a process through the HMI. A secure network architecture for oil and gas consists of 4 primary zones. The cell area zone. This zone consists of devices, drives, sensors, encoders, and controllers within the system. It's in this zone where most of the physical processes take place. The process zone. This zone consists of network services and switches. From this zone, site operators can observe and control or track and report on cell area zone activity. A demilitarized zone. This zone consists of backup servers and firewalls. From this zone, applications and data are protected from unauthorized access. Enterprise network. This zone consists of network access through the internet over wireless communications. From this zone, employees and vendors can collaborate and share data remotely. Using the Pera model to see the big picture, the overall architecture of an oil refinery network is divided into 4 segments: the enterprise zone, the demilitarized zone, the process zone, in which the oil and gas industry would be the refinery, and multiple cell area zones, which are divided by the various processes within the refinery facility. To maintain steady operations, the first key goal for IT is availability and redundancy. Access to data in the networks in the process and cell area zones must be managed and controlled to maintain the availability and stability of refinery facility networks. Best practices of implementing the process zone include replicating critical network services such as domain services, such as LDAP or Active Directory, naming services such as DNS, IP address services such as DHCP, time services such as NTP or PTP, applying redundant network routers, switches and links to maintain overall network availability, and utilizing redundant topologies to achieve availability such as ring, redundant star, or wireless mesh topologies. Creating a secure connection that links onshore wells, offshore drilling, pipelines and refineries together in one global network poses a lot of challenges. At the very least, the following issues must be addressed: hazardous environments, remote collaboration between systems, global experts needing to connect and collaborate across many miles. The high demand for oil and gas makes it critical that operations are running continuously. Networks within the oil and gas industry must be reliable and therefore require a high level of redundancy. They also need to be accessible by mobile devices and remote operational areas. To support these requirements, a combination of ring, dual ring, and wireless network topologies are used the most often. The ring topology is quite simple from a physical perspective. All devices are connected to 2 other devices, one on each side, forming a closed loop. Transmissions travel through the loop in a specified direction. The benefits of using a ring is that it supports redundancy and there is no single point of failure. They are also often inexpensive to install and easy to maintain. In the ring topology, Ethernet network loops are managed by means of spanning tree or rapid spanning tree protocol, which require anywhere from 6 to 50 seconds to recover from a network failure, depending on whether STP or RSTP is used. When a resilient Ethernet protocol is implemented, network and application convergence typically occurs within 200 microseconds and can be as fast as 50 microseconds when the protocol is configured over fiber optic uplinks. Dual ring topologies are formed with two concentric rings which connect each device on the network. Each device is still only connected to two other devices. Dual ring topologies require the use of a loop control protocol such as REP or STP. Dual ring topology provides more redundancy and availability than a ring topology because it can tolerate two failures within the network at the same time. If one ring fails, the other ring still operates. The disadvantage of dual ring topology is that it is more expensive to deploy because it requires twice as much cabling and additional switch ports that are usually fiber. Wireless networks are a critical component in creating a unified oil and gas network where there are harsh environmental conditions, long-haul pipelines, and many remote onshore and offshore drilling sites. Wireless devices are more vulnerable to environmental conditions than hardwired solutions. There are challenges with implementing wireless devices within the harsh and oftentimes hazardous conditions surrounding the oil and gas industry. However, the implementation of wireless technology is necessary to connect the fast-spread oil and gas infrastructure. When developing a wireless approach, the effects of conditions like extreme hot and cold temperatures, outdoor exposure to sun, wind and rain, and loud vibrating machinery on wireless equipment need to be taken into consideration. When selecting wireless products, look for rugged and hardened devices that are rated for harsh environments, ATEX Division 2 Zone 2, rated for extreme temperatures, protected against dust particles and moisture. The Cisco First Mile wireless solution allows on- and offshore oil facilities with harsh conditions to connect through a wireless network. Cisco First Mile Wireless enables communication to remote devices and controllers. It also integrates mobility services such as wireless voice over IP, video, and guest access. Wireless refinery solutions provide a converged, standards-based architecture for applications that monitor and gather data right down to the sensor level. They help oil and gas operators to improve operational efficiency, create and adjust business processes, comprehensively manage the refinery site. A secure wireless architecture for the oil and gas industry consists of the following components. A wireless sensor network. This network contains a series of automated sensors that can track real-time movement, monitor conditions and log access to facilities and the network, for example. This level of detail supports consistent, condition-based monitoring to assure high performance from equipment at all times. Wireless backhaul network. This network is used for remote data access in environments where wired networks would be inappropriate or not cost-effective. Together, these components allow oil and gas operators the visibility they need to maintain smooth running operations and to ensure assets are protected. In the oil and gas industry, it is critical that employees are able to access the network from remote areas. Between employees isolated at drilling sites and those performing roaming pipeline maintenance, the use of remote VPN access enables authorized people to securely access the network from any location. Remote access VPN solutions include the following options. Clientless SSL VPN. Access provides network limited access and is an ideal solution for vendors and contractors who should have limited access to a very limited set of resources. Full network SSL VPN access enables users to access to any resource on the network, including applications, and is an ideal solution for those who need remote access to the same network resources they use in the office. IPsec-based VPN enables remote access through a pre-installed VPN client software on the user desktop. This solution is primarily used on company-owned computers and is ideal for modifying VPN clients to function on applications such as unintended kiosks. Advanced security policies are implemented to limit remote access to authorized people. Such strategies are important for oil and gas producers whose workers are often situated at remote locations and utilize a variety of mobile equipment. It's recommended to use a multiple defense in depth approach for seamless, always-on remote client compliance. Using this approach, the remote clients will be provided with convenient connectivity while enhancing infrastructure security and decreasing the enterprise's total cost of ownership. Cisco's security solutions promote information and system security with a full suite of industry-leading firewalls, next-generation encryption, intrusion detection, network management, client security, and other critical control measures. In this module, we have seen that, at a high level, the oil and gas ecosystem consists of drilling companies, piping and pump stations, refining facilities, transportation and logistics organizations, as well as consumer-facing enterprises. A connected gas or oil field will allow secure communications, enhanced safety and compliance, integrated maintenance and operations, and more effective field collaboration. The oil and gas industry is regulated by standard organizations such as FERC, ANSI, ISA, and NFPA, and ATEX fire security directives, which play a significant role due to environmental dangers. Automation communication protocols such as Ethernet IP, CIP, Profinet, Profibus, HART, and Modbus are widely used in the oil and gas industry network. Availability, redundancy, wireless connectivity, and secure remote access are requirements for a robust oil and gas industry network architecture. Oil and gas networks must be reliable and therefore require a high level of redundancy. They also need to be accessible by mobile devices and in remote operational areas.